And yeah, it was. I guess they said that it was the wind as
Oh,
the pilots as we took off again, and then they didn't say anything for like 5 minutes. The pilot then said, and there we had a slight bit of unexpected wind, and we will be landing again in 10 minutes. And I thought, that was very unexpected. So, oh well, it was all good, but it meant I missed this talk yesterday, so I apologize, people. But because they had to take off again and then loop around, and so I didn't get out in time, and there you go. Oh well, that's quite a good excuse, isn't it, right? I think that counts as a legitimate excuse. All right, people. Well, it is freezing cold in uh, the UK. Hello, Marie France. Lovely to see you. Marie France and I had the pleasure or displeasure, one of us or other, who knows, of getting to spend Friday together among a few other people, where we actually went through, which was a genuine pleasure. Um, we went through building out a neural network from scratch, all the way through to gradient descent. So look at what we did together. Look at this. We did this, people, with a small group in New York, and that's why I was traveling. And it was, look at this, full gradient descent for full ML neural network fitting, uh, building out a neural network from scratch and decision trees, and it was really, really good fun. And as always, Mary France was a wonderful member of the audience. And so I am going to look forward to starting to do that one more. I was really, honestly, it's something that will be refined over time, but I will probably start to do that one, which is a full workshop, I think kind of hard part style, 2.5 hours long thing, in online at some point. But I'm going to do another version in New York, if any of you are in New York, in a few uh, weeks. I can pin myself so that other people aren't on the live share thing. But anyway, for now though, we're going to do some more. Also, it wasn't last night. We stayed up till 4 a.m. last night, even though we just landed, because we were not missing out on what was an absolutely. I thought it was quite good. I thought it was quite a constructive discussion on last night's televised debate. It was, as far as it goes, what can be expected. I was quite happy to see that sort of thing being being part of our political space. Anyway, all right. All right. Let's dive in. That wasn't me, by the way, endorsing political, just politics, just the notion of there being a space where that sort of uh, you know, questioning happens. So I was quite happy, you know. Could be a lot worse. All right, let's go and talk about building software engineering teams. So we'll keep this one. Um, what time is it? How are we doing? It's a small group, so we'll keep this one fairly short. I think the thing I'd actually ask people is if you could put in the chat what thing well firstly where you heard about this workshop. So and if you're new, welcome, and share where you heard about the session. And then it's not a flattering light, is it? There you go. There you go. Not looking quite so gaunt in this lighting. And then questions you have as well, like things that you're curious about. We can try and even do just a back of the envelope explanation of things that you're curious about within the space, or keywords, or things you want to like ask about. Think of this as a gamer's live stream where I am happy to offer my opinion on things that I'm vastly unqualified outside of my particular gaming niche of, I don't know, Flappy Bird. No, not Flappy Bird. That's not even a gaming niche. It's a mainstream game. Okay. No one said where they are. Put it in the chat, people. I'm just trying to make sure my slides are all. Also, by the way, people, I had to take some medication on Monday, so I am quite. It makes you really drowsy for the first few days, and so I am a bit drowsy, a bit indigestion, and so I'm not at my. You see my energy level not at the maximum today. Hello, everybody. Hello, Simone in New York. Fab, lovely to have you on. Yes, please do. Uh, Rosanna, I think her name was. Maybe I'm misremembering that. Rosanna. Um, and then we got Jim, of course. Wonderful. Welcome back, Jim. Hello, hello. Lovely backdrop as well. Malay, Fab, Erica in Kentucky, Christina in New York from Meetup. Great. Good, 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 good. All right, people. So let's dive in. Let's go through this workshop. So I think we're good to go. Let me just make sure. Yeah. Okay, here we go. So we'll try and hit on a range of pieces, but I think primarily, yeah, we're going to talk about what a team looks like when you are integrating ML or AI into it as a major part of its product. So increasingly, and Codesmith talks about this quite a lot, the stack is expanding. So the full stack engineer is the stack being the fancy word for the categories of technology, whole categories of technology that you work with. So front end is the category of technologies that you use to display stuff on the screen. Primarily, it's complicated. Don't underestimate it. The back end is a category of technology you use to supply the stuff to be displayed on the screen and to retrieve it from a lot of databases. That's the back end. Another part of the stack might be infrastructure. That's the technologies that allow you to do that for maybe millions of users at once. Another part of the stack now is prediction. That is integrating into your product the power of prediction. And prediction is predicting or modeling from prediction from modeling is prediction of users' behavior. Are they making a fraudulent refund claim on DoorDash or not? But it's also prediction of the categories of images. Is this an image of a cat or not? Is this an image of a cat sitting on a chair or not? But it's also prediction of literal pixels. Are these the best combination of pixels that responds to the prompt cat sitting on chair and then produces that combination of pixels? It's also combinations of words in response to other words. In other words, conversation, chat, or chat GPT. These are the predictions that you can now integrate into your products as an engineer. And the thing is, like front end has similarities with existing with back end, and back end has similarities with infrastructure. Prediction has similarities with infrastructure and back end. Deploying a model looks a lot like infrastructure and a bit of back end. Thinking about, honestly, thinking about data pre-processing pipelines has some similarities with some front end stuff you'd do before you pass it to a server or an API, some data collection, some data interaction. Pre-processing as part of, we'll see what it is, but pre-processing being ensuring that the model's input is efficient and or consistent. That's got some similarities to thinking about, as a front-end developer, how you would structure a request to an API. A lot of crossover, but just like front-end and back-end end up being really whole domains with a lot of fundamental mental models that go in. Front-end might be what you see must be consistent, what's going on under the hood, known as view and state consistency or reconciliation. That's a key part of front-end development. Back-end development, it might be I don't know, it's not perfect, but a request response structure with a middleware pattern handling a series of tasks that a server has had received as a request. That these may be fundamental principles that you're not going to see as much between the two different spaces. So too, this domain of the stack that I will call prediction has some fundamental pieces that are quite distinct to it. There may be lots of crossover with front end and as a software engineer, there may be lots of crossover between the infrastructural things that you can set up, but prediction has some distinctive aspects that I would consider you need to invest in understanding to be thinking of yourself as, in this era, a full stack engineer. It's a whole new piece of the stack that I would call prediction. And hopefully today we can kind of get a little bit of a sense of those. But the prediction you more colloquially might call machine learning and artificial intelligence. I like to think of it as prediction because I think it's a little bit of a counter the like I don't like to say cloud because anything that could be, and I think The Economist writes phenomenally on technology actually at times, but anything that could be, used by a fraudulent LinkedIn talking head trying to sell you something, dodge, like the word cloud or AI, I'm always just like, oh, it loses a lot of it. So I like to think of it as infrastructure as instead of cloud and prediction instead of AI, but they are, interchangeable. So anyway, we'll get a grip of that. But just the sponsor of this workshop is, yeah, I can share the slides right now. The sponsor of this workshop is Codesmith, which is the software engineering immersive thing that I run and we founded about 10 years ago. So I guess to maybe save us going through all these slides, actually, it can sometimes be nice to look at just the homepage because it just gives a quick sense of the overall mission and vision of the program. We cultivate technologies through an intersection of society and tech, able to meet this moment, which is one where there's suddenly a whole new piece of the stack that, by the way, opens up a vast set of problems that previously you couldn't really solve with software now become possible to solve with software, which is really cool. It's like kind of incredible. I like to have this provocative statement. Codesmith is a boot camp. I don't know if we need to put that in quotes or something, where nevertheless you become, well, to be fair, it says mid/senior. As many people who become senior become junior. So it's mostly mid, but about 15-20% of graduates go to senior or principal engineer roles, and about 15% of graduates go to junior roles. And also the terms aren't that definitive. But the key point really that's my proudest thing is you might learn JavaScript or TypeScript at Codesmith, but you're really going to end up doing any number of other languages. In other words, you become a software engineer, not a React technician or a kind of, which is important, especially if you think about this era where technically it is possible to generate some boilerplate code at a rate that's unprecedented. So you better be understanding the deeper principles. That's the point of the program. And therefore build some pretty revolutionary things. In fact, we mentioned pre-processing layers, TensorFlow, which is one of the I don't know what the phrase would be. I was going to say granddaddy, but that's a very silly old-fashioned phrase. One of the behemoths in the neural network space and the deep learning space, that pre-processing layers or a small piece of the pre-processing tooling for TensorFlow JS, which is the JavaScript library implementation of TensorFlow, was developed by a group of Codesmith students, which is, gives you a sense of the kind of groundbreaking, hopefully, work you're doing, despite it being a coding bootcamp, which you're probably not expecting to do groundbreaking work at, maybe. And then a really cool collection of people where the top two majors are computer science and psychology. What a cool juxtaposition. Okay, so that just gives you a sense of the program. And that creates a really good mix of interesting. We need to update this actually, because now we made this site about 3 months ago, and so now these graduates look a bit longer ago. But yeah, so yeah, you can see a real range. And this is what we're talking about, these AI teams have increasingly a range. So I listened to an ad. I was actually saying this with the talk Marie-France was in on Friday. I was listening to a podcast and an ad came on. It's like, we are building with AI, but with our expert engineers who also understand the domain that they're building in. And I was like, oh, and then it goes AI like, oh yeah, our legal tech, our legal engineering tools, our software for lawyers that's built on AI, but with lawyers at the center of it. And I was like, huh. And then it goes Thomson Reuters because the people behind the AI matter or something like that. And I was like, oh shit, that's we have a grad whose job to get the job she got required her to have 2 years as a lawyer, a JD, and also 2 years in Python as a software engineer. And she got that straight out of the program. But that's like they're now advertising that offering. And that's really important to be aware of, people, is that large companies are terrified of implementing AI in production. So that's that role here, software engineer, legal prompter. You've got to understand the law and understand the engineering. Large companies are terrified of productionizing AI because of, the edge cases that they know they can tackle new software domains. Like suddenly you can give legal advice, but the edge cases are so high risk that you need engineers or builders who can work at that intersection. That's one of the things we'll talk about today. But yeah, there's also more classic like ML engineer at TikTok. So anyway, seeing a whole range of, or program manager. That's a role where it's like, hey, I'm technical, I can understand the engineering, but ultimately, am I writing code? Probably not. Or a bit, but I could never do it without fully understanding the system design. So there's a lot of interesting movement going on right now, while also a lot of regular software engineering roles. But there's a lot of interesting movement. So that's really what we're trying to go through here. Um, so we don't need to dwell any longer on the Codesmith stuff. Let's just dive in. Um, if you want to find out more about Codesmith, feel free to, explore any of these things here. But okay, so let's hit on some key things I want to talk about in this workshop. I wish I had my iPad to diagram. It was so nice to be back on a whiteboard. And please, people, continue to populate the chat with questions you have. Um, but yeah, let's talk about. I think the thing I really want to spend some time on is here. So let's move this up, and we'll just focus on this for a bit. So expanding the stack doesn't, as a software engineer, to add prediction or AI ML does not mean that you are becoming an ML engineer. I actually don't think it's beyond possibilities, but there is a whole piece to add to that puzzle that is quite challenging. We're not looking to be that. What we are looking to be is the software engineer who has this full stack, including prediction, meaning they can work right up against and with and collaborate with the data scientists and machine learning engineers. So what does that look like? Well, let's take a look at a team in this era. So I actually would perhaps start with a different example, which I had from Friday, which is the productization of, or the productizing of prediction in a product that maybe many of us know, DoorDash or Uber Eats. So DoorDash has automated, and this is what a lot of this is about, prediction is automating computationally, making a prediction, a choice or behavior that previously, or an insight that previously took manual work by a person. In the case here of DoorDash's refund product, it's automating the decision, is this person who's requesting a refund because their item didn't show, is this a fraudulent claim or is it not? And we had a great time on Friday thinking what factors might come into play in the data that's going to train the model. That's going to be the sample from which we make a prediction about the larger population, which is anybody who can make a refund claim in the future. The sample might be 10,000 prior refund claims or 100,000. But every one of those refund claims might have a wealth of information about the user's behavior that go alongside it, like the number of requests they previously made, obviously, the size of the basket, how much did they spend, the zip code, the time between making the request, time between the arrival of the food and the making the refund request, the number of prior refund requests they've made. Did I say that one already? The number of refunds that have been on that IP address before, the age of the account. All of these would be factors in our sample of prior refund claims where then a customer service rep, a real person, has made a judgment to give them the refund or not. The machine learning training process, and again, we're not going to dwell too heavily on these pieces today, more talk about the larger team structure, but the machine learning training process to build the model that will allow in future the automation of that decision. Do we give them a refund or not? Its primary job is to find out what factors are important in the sample, the prior cases, to determine whether the customer service rep decided, is this person worth giving a refund to or not? Is this a fair refund request, or is this someone trying to fraudulently get a lot of free food? And machine learning is the process and is a discipline of trying to design and come up with structures, boundaries, models that can translate, in this case, per each user, the information on their account with whether or not their refund was approved by the customer service rep or not. And that allows in future us to be able to convert that user's set of history into an automated decision. Do we want to give a refund or not? This is commercializing or productizing prediction, a small sample of prior users being used to generalize to the entire population. All of machine learning turns out to be taking a small sample. In case of a large language model, that small sample is all human language use on the internet. All the sentences, roughly, that humans have ever used on the internet. But it's still a small sample compared to the population of all possible human language use that could ever be made. But the model looks at the sample, or human language used so far, and sees and identifies the patterns. What is the best predictor in a given sentence of what the next word will be, and uses that when we have a new word or string of words or question asked to make a prediction of what the next word should be in response in the user's future. It translates that model to the larger population, uses that model for the large population. But that's no different to this. It turns that we're working with a much larger sample, but we're still ultimately making predictions from a sample to a broader population. In this case, the sample of prior refund requests, from which we then make a prediction for future ones that can be automatic, not based on human judgment. It comes with a whole wealth of problems. The systemic biases that might be in those prior judgment calls, inaccurate models, essentially. They're not actually good at predicting whether or not the person legitimately deserved a refund or not. But you can see here these two different screens, which is, by the way, why it's so important to have people in these fields who think through deeply those questions of, are we designing accurate predictions that also reflect the values of the organization? Because we ain't going to have a human judgment on every single case from now on. It's going to be automated. Do we have fallback options where if we reject it, there's reasons to be able to make a claim? Excuse me, I claimed that I had my food didn't show up. I asked for a refund. It automatically rejected me. Why? Give me the ins and outs of that decision, right? And these are all the parts that make up data science, machine learning policy. Safety refers to that sort of alignment, refers to, is it aligning the model with the values that we as a company want our model to make predictions around? There are implicit values or implicit elements of that decision. And is the product around the prediction also aligning? So, for example, if the user is not able to, upon getting a rejection of a refund claim, appeal, essentially, in the product design, that's a bigger problem, the decision that's made about their refund claim, than if they're able to appeal. If they're able to appeal with a quick button, okay, maybe it's not so bad. These are all the questions that come into your job as a software engineer in understanding the nature of prediction. Okay, so here I love these two screens because I do think that building the product around automated refunds based on an ML model is an amazing thing. But you can see here for also like the automated, sorry, you've got too many refunds. Because remember, with all prediction, you are going to be making a generalization from a small sample. It may seem like a lot. Maybe the 100,000 people they're basing this off, 100,000 refund claims historically they're basing this off. But it's still small compared to the possible set of refunds that could be asked for. There's a possible number of accounts, the possible nature of the accounts that could be asking for a refund. And yet you're using your model from the small sample to generalize the broader population. And by the way, your broader population might change, might evolve. What if once it's automated, the users change their patterns of behavior? Now they are less likely to make a refund request or more likely to, opportunistically, because it's social pressure is lower to make a fraudulent refund request, for example. Now your sample from which the decision-making model was made is no longer reflective of the broader population. That's what model training, iteration, alignment, refinement, that's why it is a permanent job of updating and improving that prediction as the sample becomes less relevant to the population. But these are the things that I'm looking forward to building into a longer form talk, but are interesting things for you to think about as software engineers. The other product, the one I want to focus on a bit, is this one here, lex.page. So Apple's AI products, Apple Intelligence, has a bunch of built-in proofreading stuff. So does Grammarly, so do a lot of ML-based tools. They're designed to try to get good at predicting patterns of words based off a sample of used words in sentences, so that they can then make predictions for the entire population of how human language can be used. Well, this product here, lex.page, is like Apple Intelligence proofreading offering, is an effort to create a proofreading tool for for a Google Docs kind of product. What's the team look like? Okay, so lex.page allows you to write some stuff, highlight a bit of it, and say, make this read more formally, or make this read more expressively, or make this read more colloquially, whatever it might be. That product, don't get me wrong, the prediction bit in it is really cool. The actual entire product is vastly beyond just a prediction piece, but let's talk about the prediction core piece. It's only a piece, and we've got here the rest of the app to be built, but let's focus on the prediction piece. Okay, so the data scientist says, give me a sample of likely text phrases or collections of text, or a corpus. This is the fancy word within data science or machine learning for a collection, a body of language, a collection of language, a corpus of how formal language reads, how colloquial language reads, how entertaining language reads, how expressive language reads, how persuasive language reads, and then give me a corpus of not that. And ideally, potentially, give me like for like comparisons. Here's the vanilla, here's the expressive version of it, the comedic version of it, the formal version of it, the persuasive version of it. There's your sample of how human language is used in those different settings. And now use that sample to spot what are the best predictor combinations, what are the most important factors that convert, that transform, that map your vanilla text into comedic text. Now, you have to have captured words and their placement in sentences using some mathematical structure. Different talk, but that's a core part of large language models, capturing how language in a given sentence is related to each other, how this word in the I love my ginger cat, how is the word ginger related to the words around it? That capturing human language as tokens, individual pieces of a word or individual pieces of a sentence, and how they relate to each other is a core part of a large language model. But the data scientist's job is to take those patterns of or those mapped vanilla to expressive to persuasive to comedic to formal, and identify what are the key features of the expressive, the persuasive, the funny, the formal, and now generalize that. That's your model to be generalized to the broader population of all possible combinations of language, which would allow, in theory, the model to receive a scrappy or vanilla, not persuasive, not expressive, not formal, not whatever, text that it's not seen before. It's from the broader, what they call population of possible. Population is all possible ways in which human language can be used. It's from the broader population of all possible ways human language can be used as we recognize it. We're not talking human language being used randomly. We're talking used as a human would recognize it. And from that, it can apply the model from its sample where it's learned how to convert vanilla into formal, vanilla into comedic, and it can apply that same model to this new, as yet unseen piece of text. That's the data scientist's job, to build that model. And it's an experimental thing, it's a creative thing, it's a scientific thing where you're tweaking. You may do it on your own, what they call local machine, like your computer, not on the internet. You may do it with a smaller sample size. You may not mind if it's incredibly initially inefficient, a process of working out the patterns in the sample text, as long as you're getting the right direction for what the model might be. This data scientist is reading the latest papers that say, research papers, that say, hey, we're identifying that actually using this new technique for capturing language, for removing this bias, we're seeing this new technique, try it out. And then another paper that came out 2 months later saying, actually, we found if you tweak it this way, it performs even better. That's your data scientist. At their core, they need to make the prediction accurate, get it really good at converting vanilla text into the formal equivalent, vanilla text that it's not seen before into the formal equivalent. This is not a product, people. This is not sitting on the internet. This is not an experience. This is not quick. It's not efficient. It's the scientists refining and working on this themselves. Then you've got the ML engineer. The ML engineer has to understand a lot of what the data scientist is doing, because their goal is to take that model, which maybe was done kind of initially on a fairly small scale on the data scientist's local computer, is it going in the right direction, and ensure that it is scaled up. Maybe now it works for a lot of edge cases of how humans might use language, that it is fast, that it doesn't cost a ton of money, especially given we're going to see in a moment that the model that depends on generalizing from the sample of examples it's got of vanilla, formal, comedic text, that actually it's going to get a whole bunch of new samples it can use as soon as the user starts interacting with it. As soon as the user starts playing with, please proofread this, make it more formal, and then it tweaks, then the user tweaks their response in response to the prediction from the app. As soon as that happens, now the data scientist is just overwhelmed with new data to refine the model. The ML engineer is like, we do not want that refinement of the model to cost us another, $5 million, no, $2 million to retrain our model, paying NVIDIA $2 million in the process. The ML engineer has possibly the hardest job of all. I don't know, what he's because they have to deal with understanding the math that goes into making the prediction good, the data scientist job, but also they've got to try and get that to be cheap, fast, online, so that it can be actually used in production. And then also, ideally, up to date with the user's latest tweaked text that becomes the new data for the data scientist to improve their model. So the ML engineer also has to understand computers, web systems, API design. So the best ML engineer truly sits with software engineering and data science underneath it, within their domain of knowledge. Domain of knowledge? Yeah, domain of knowledge. Yeah. Okay. Then there's the software engineers. And damn, suddenly I hope you can start to see you can play a major part here. At this point, the best you might have to be working with, the best you might, and it's very, very unlikely, would be that doesn't even make sense. I was going to say a deployed model. That means that technically there might be an API endpoint that you can write a request to that will pass very precise structure, in this case of text, that is ready for the model to convert from vanilla into, let's say, funny, or vanilla text into persuasive. But ask yourself there, what does that actually literally mean? Maybe the model's deployed, maybe there's an API endpoint that you can pass that text to, but what format does that text need to be in? Is that text going to be the entire body of text that the user's highlighted? Can the model handle that? Is that text going to require some pre-processing stages? Remember that a model is trained on a small sample, the training data is fitted on a small sample to be then generalized to a population that should look a lot like what it was trained on. So if it was trained on 50-word samples, 100-word samples, 1,000-word samples, the population that it's going to be used on better look very much like the training data, because you are generalizing from a sample, the training data, to the population at large. So you, as the software engineer, may have to do a bunch of creative stuff to pre-process the data and ensure that what's being passed to the model reflects the kind of stuff that it was trained on, as in within the same population, the same broader category. Population of all pictures of cats is a different, or population of all 3x4 pixel images, or let's say 100 by 200 pixel images, is a very different population to all 4 by 400 pixel images. You would need to pre-process that data, ensure that it looks the same as what the model is expecting. But then what about when the user gets back their response, which is the, let's say, formalized text or the comedic text? What about when they get that back? It firstly needs to be post-processed, handled in some way, but also they then start tweaking it. They start saying, oh, I don't like that little bit of phrasing there. Let me change that. That is vital data to improve the model's performance. How are you going to pass that? I mean here, I guess actually, honestly, literally could be either, right? PARSE, how are you going to break those changes down? And PASS, and then pass that to the, I guess, ultimately data scientist, but via the ML engineer. If the user is making incremental tweaks to the text they're editing, are you passing those back as incremental changes, snapshots? Are they being passed back as, I don't know, a whole body of text? Are you doing it for a few words in a subset bit of the sentence that's now more training data? So do you see like how much as a software engineer integrating the prediction? And I said at best, you have a fully designed API that you can just make a call to that gives you the prediction, the text, in this case, the formal text back. That's the best case scenario. You may literally be helping the ML engineer deploy the model. You may be designing the API endpoint with the ML engineer. All of these things to me require you, in my view, I think it's reasonable to have a strong understanding of the notion of prediction, which includes the mental models of what are you doing when you're designing a model. Too many use of the word models there, but you're including the mental conception of what are you doing when you're designing a model, when you're building a model, when you're refining it, when you're training it. What is it I wrote on that talk yesterday that I showed? It was become the software engineer who can look at the training data sample and take a quote stab at pre-processing stage to provide to the production model. Like that's a kind of playful quote of like what I would want as an ML engineer, a software engineer to be able to do. They're not building the model, but they are able to look at a training data sample to take a stab at the pre-processing stage to provide to the production model, so that they're able to work right up against the ML engineers. So that's what you want to do. And then there's software engineers building the rest of the damn owl, you know, um, and there's, a wealth of different pieces here. One is it's a very legitimate thing. It's not easy to do smart prompting, working well with automated or, with Copilot or other similar tools. That's not a nothing. Those aren't like cheats. Those are things that you do need to understand the, um, let's call it prompting heuristics, the behaviors and approaches in prompting your model, your Copilot, or literally your GPT, your ChatGPTs of the world, or Claudes, Anthropics, Claudes. What are the heuristics? What are the uh, techniques that rest on a principled understanding of the nature of those models? And that's the other reason, by the way, to understand the nature of prediction, is that it also is going to enable you as a software engineer working on the rest of the stack. And that's my point, is that the different parts of the stack do cross over with each other. Understanding the nature of prediction will make you better at, in your front-end engineering, integrating prompt-based code creation. Knowing better the nature of prediction and the nature of a large language model makes you better at prompting heuristics, getting better at doing good prompts to write good code. It's not just luck, it's also you understand the nature of how those predictions are being made by the model. And the predictions of code are being made by the model. What's it trained on? How's it handled edge cases? There's also an emerging space of, I would say, out of the box, you can get using it straight away, prediction, or in this particular case, large language models, that enables you as a software engineer or an engineering team to implement some lower level models suited to your product without the need for an ML engineer or data scientist. And so that's an expanding area as well. What I would stress enormously to you, firstly, is I'm really excited to share, the ML hard or the AI hard parts type stuff. And so, as I got a chance to do the neural networks one, where we really built out a neural network from scratch and took it all the way through to multi-layers, and really got to I think a strong place where we're able to think in terms of hopefully placing many key terms and key aspects of neural networks, deep learning, artificial intelligence, into a framework, so that when you see terms like vanishing gradient problem and ResNet, or residual neural networks, as a approach for handling vanishing gradient problem, you go, interesting. Now I could see how there could be an exponentially decreasing gradient when in backpropagation we're losing some of the signal over time in many layered deep neural networks, that then would make trying to adjust weights to improve the model's accuracy pretty much impossible for earlier layers, unless there was some way of skipping or capturing the difference between layers that are many layers apart. And suddenly that not perfectly captured thing there becomes not what, but becomes, oh, well, yeah, that makes sense within this framework. And so that's why I think it's really important to add. And I've had the chance to do hard parts on UI, on server architecture, on programming fundamentals. And it's really important to have these frameworks of thinking for prediction, or let's call it AI/ML. And so I think it's very much worth investing your time in building up those mental models to be that software engineer who, I say ML ops here, but really, works closely with prediction. But also, I would stress to all of you that it only means more than ever that the things that we hammer home and hammer on about at Codesmith, which is problem solving and technical communication, only become more important when the tools are clearly evolving fast, when the kinds of problems that can be solved are so new and exciting. Don't get me wrong, engineering is still messy and complex. I don't care, you know, I know it doesn't get it it doesn't get it doesn't stop being very challenging. It's still, edge cases are still very challenging. Sourcing out the bug and understanding why is challenging. Making choices without understanding why is challenging. But it's definitely a new set of domains that can have that approach applied to it. Some fun recent examples, people. Oh my goodness, what was the one I just read very recently? Oh, God, I watched a bunch of Andrew. I think you know Andrew, right? Some of you will know the defense contractor worth in the tens of billions, that is approaching US and allied defense, and putting aside thoughts on that, but through the software defined layer. Don't get me wrong, they're building great hardware, but they consider their core product to be a software layer. Defense contractors make physical stuff, as they describe it in their work, they describe it as exquisite items. That's what Andrew describes, what Northrop Grumman and what these major defense contractors produce is exquisite items. And they're like, war's changing. And it's that software layer. That's flipping, there's nothing more physical than a warship. And yet for them, they recognize software layer is the cornerstone of where the problem solving is happening, let alone legal, let alone telecoms rollout, let alone it's ever more the center. And a big part of that is because you can now integrate nuanced human-like decision making, which is essentially prediction, generalizing from small samples to global patterns, global populations, the patterns you see in small samples. So small samples might be human language sources, therefore huge samples, but population's even bigger. It's all language use by humans, or it might be other topics, but it might be within a domain. It might be choices. It might be, but it's incredibly central, but it only requires greater flexibility to take on those new problems and be able to push through the blocks. And the same thing on that is technical communication. If you're now building software for military or building software for education or healthcare, because now you can tackle all legal advice, because now you can tackle those, because the scope of problems has got much bigger, because you can use prediction, which opens up a whole range of nuanced areas for software. You better be able to explain what and how you're doing to those around you, to all those non-technical stakeholders. And I don't even like the distinction of non-technical. I don't think they are non-technical. And that's really the point of Codesmith, is that I like the idea and always have of people running stuff in tech, quote, who remember tech running them a bit, not always the other way around. Because especially when you have seismic shifts like this, you need people who remember it being a bit of a black box and it being applied to unto them. And then when they're the ones applying it unto others, they can't help but remember, oh shoot, I better actually, if I'm rejecting automatically as part of the product someone's refund request, I better be giving them a kind of why. I better make sure that model can actually have visibility into it, can actually be digestible, and therefore highlight the primary factor the rejection happened. You have too many accounts on this IP address, whatever it might be. Because I remember black box of text make tech being a confusing thing, and now I'm the one making the calls. And that is the underlying premise of Codesmith. Take people, I don't care how successful they are, and obviously many are very fancy success pre-Codesmith, but who then, whether they did computer science, and we said at the start it's number one major, but that, is still whatever that is, 7% is the number one major of graduates, 7% of people doing Codesmith did computer science or something like that, right? Like it may be the number one major, but it's not like huge. The point is to have people who, however bloody successful they were before, tech was not, one of the weapons they wielded in quite the same way as after it becomes a weapon they wield. But hopefully for greater good, because they remember it being wielded on them, if that makes sense. So that's why I think this matters so much here, people, is especially as the kind of problems that can be. So just feel proud also, folk, that that's what your measure is, not just your knowledge of these things. Okay. Thanks, everybody. Really lovely to have you all on. Oh, we had Chris question, what do you think is the biggest challenge engineers face when transitioning to these new responsibilities, and what's the best way to prepare? Um, I think not knowing where to begin is very difficult. I think a um, I think I think you can go a hell of a long way with intuitions and principles, but there are not a huge number of spaces to do that. And much content does understandably prioritize some truly hard to get your head around math. Like if you're not really familiar with linear algebra and calculus, that is boxes of numbers and I guess roughly, XY axes with chart graphs, right? If you're not like familiar intimately with those, then you will not be able to read a research paper. I think that's fair to say. Like, I think it would be very challenging. And I think that means that it's much harder to feel comfortable, confident at home. I think one of the biggest things that I want from not today's workshop, but from some of these upcoming workshops is the ability to give you some of those little things that I always love giving you in hard parts of programming that all the computer science grads, know the distinctive nature of, I don't know, lexical scoping. Like they know these things. It's quite fun to give a little bit of, and actually Marie France pointed this out to me, a little bit of that ownership on those principles, not to be able to walk up to a data scientist and go, I don't appreciate the work you're doing, but for it not to be something that maybe there's a reveling in the obscurity of it, because actually it is very much some core principles. And the math around them for sure helps implement them. But the core principles actually are a lot more about probability and stats, which is not as obscure. It mirrors, many of the mental models we have in our lives. So anyway, that's for me the big thing, Chris, is that particularly this is a place where the scientific math and academic obscurity is a meaningful thing, but it's not unassailable. AI engineer. Oh, great question. Um, I I think it's I honestly, it's a see the article. I honestly think it's just, yeah, I would say ties. Yeah, this feels, you know, not a million miles away of it being closer to. This is kind of exactly what I mean, the chains agents, I guess that could be almost like an infrastructural piece. Um, it's interesting. It's still very, very much emerging. Um, yeah, it's still very much emerging. Obviously, we get more grads getting AI engineer than ML engineer, right? So ML engineer, we know what that's definitely the productizing of specific models. Um, sorry, productionizing specific models. AI, and that's, or what do they say? Data and inference, ML engineer. What did I say? Productionizing specific models. Well, productionizing models is data input, inference is prediction, and I guess making this production. Yeah, they're saying, I don't know if I 100%, I mean, yeah, AI engineer. I, honestly, it's not a million miles away from all the stuff we were talking about, but you're like a front end engineer only doing the front end part of the stack, a full stack engineer doing, a back end only doing the back end. It's like only doing the prediction bit, but not necessarily with the same depth. I would say I've not yet seen as much AI engineer as full stack engineer where you have an edge if you're able to truly. I would say better to think of yourself as a full stack engineer where you could take a back end role, you could take a front end role, knowing that if you take a front end role as a full stack engineer, you're going to do a bunch of back end adjacent stuff. Take a back end role, you do a bunch of like front end adjacent stuff. You're doing infrastructure regardless. Take an AI engineer role as a full stack engineer, a lot of it's going to be looking a lot like front end, back end, but also the bit that involves prediction that we talked about here is much larger than it would be if it were a general full stack role. It's still emerging though, JT. But I will read this article as well. I'll be interested to see the take from already a year ago, so probably out of date already in this space, right? I mean, you see this stuff sounds a lot like it sounds a hell of a lot like well, sounds a hell of a lot like an ML engineer here, this bit. So we'll see. I mean, we'll see how it evolves. We'll see how it evolves. But I'm most interested for now, JT, in full stack engineer, which remains 90% of the postings, but that have AI bits or ML prediction bits, and that you can really stand out regardless once you're on that phone screen and they may not even fully list it. They might say familiarity with latest AI tools, whatever. But then if you can really stand out there, which is what I hope some of these things we saw here can push you in that direction, and then look out for other workshops on neural networks under the hood, LLMs under the hood, can really help you win in that market, I think. Okay, people. Thanks, everybody. Lovely to see you all. Sorry for going over a bit there. Chris is in the chat. If you want to reach out to Chris and join Chris's, Chris does amazing workshops, weekly study sessions. I'm sure maybe Chris could even start some study sessions around some MLAI stuff. That could be fun. But look out for Chris in CSX Slack. If you're not in the CSX Slack, I encourage you to get in it. Oh, I can give you my LinkedIn, people, so you can follow me on LinkedIn. Here we go. There's my LinkedIn. Let's look at the hello to our YouTube viewers. Let's put in my LinkedIn there. But I'm always surprised by how anyway, all right. Good. I was going to say how kind people are to do likes on the YouTube thing. Anyway, all right, people, that's it. Bye bye. See you, everybody. Cheers, folks.